Okay, so this is a video about mass spectroscopy and how we can use this to find the relative abundances of different isotopes of an element. So we're going to look at isotopes of phosphorus today. What is an isotope? An isotope is an atom with the same number of protons, so it will have the same symbol, but a different number of neutrons. So the neutrons will change. It will also have the same number of electrons. So let's go through how the machine works. It's made up out of 4 parts. An electron gun, which sounds kind of cool. It basically fires out electrons. An electric field, a curved magnetic field, and a detector. So what's going to happen is your sample, so your element with all its different isotopes, with their different numbers of neutrons, is going to get added to your machine. The electron gun fires electrons at it, and that actually pings off an electron. So it causes your elements to lose an electron and gives them a positive charge. Your sample then hits an electric field. Now, as it has a positive charge, it will get accelerated by that electric field. It'll start going really fast. It will get to the curved magnetic field. And here's where the interesting bit comes in. Because as it has a charge, your magnetic field will deflect it. It will curve your element. However, depending on the mass of the element, will determine how much it's curved. So lighter things are easier to curve. It would be easier for you to change the direction of a mouse than it would an elephant, right? So let's say I've got 2 different isotopes, and let's say my red isotope is lighter. It has less neutrons. That's going to get curved more by the magnetic field. Whereas my heavier isotope won't get curved as much, so it will hit the detector at a different spot. And that allows the machine to determine what the mass, the relative mass of your isotopes is. So I've got an example graph here. We're going to have the abundance of the isotope, so how much of it there was, and that's on the y-axis, and the mass of the isotope on the x-axis. So you can see in my example here, I've actually got 3 different isotopes with the masses 30, 31, and 32. You'll notice the scale actually says m over z, which is mass over charge. But remember, the charge they got is 1 plus. So this is basically just the mass, because a number divided by 1 is just the number. So you can just think of this as the mass. What I'm going to go through now, and what you need to know, other than the definition of an isotope, is how to use this graph to calculate the average atomic mass of your element. And there's a little equation we do. We do the AR, which is the atomic mass, the relative atomic mass, and that is equal to your first mass times by your first abundance, add your second mass times by your second abundance, etc. So if there's a third one, it would be your third mass times your third abundance. If I had 4, fourth mass times fourth abundance. And then as these are percentage masses, all my percentages should add up to 100. So I then divide by 100. So let's apply that to this graph here. So my first mass is 30, and my first abundance is 29. My second mass is 31, and my second abundance is 61. And then 32 and 10. All divided by 100. Now when you bang that in a calculator, it comes out as 30.81. So this particular sample of phosphorus has an AR of 30.81. Now you can actually get, if you look at a periodic table, you'll see that's not the number on a periodic table. And that's because depending on where you take your sample from, these different isotopes will have different abundances. In certain parts of the country, maybe there's a bit more isotope 32. So don't expect your answer to always agree with the periodic table. It does depend where you get your sample from.